So in the last part of this, we talked about finding logarithms, right? And what was a logarithm? A logarithm is just a what? An exponent, right? And here we have logarithms of all sorts of bases. Like here, you know, I have base of 2, I have base of 5, right? A base of 8, and so on. And so obviously a logarithm can have any base because a power can have any base, right? Any base can be raised to an exponent. The most common by far is a base of 10, right? So common logarithms are logarithms which have a base of 10. And the reason why they're called common logarithms, honestly, is because they're the most common. You see them most often, okay? They're so common that when we write common logarithms, we omit the base and simply write log x. So for example, if I have log base 10 of x, I can just write that as log of x, right? Just like we never write x to the power of 1, do we? We just write x and we understand that it's a 1. It's the same thing with the bases of 10. Okay? All right. So let's talk about powers of 10, right? 10 to the 1 is what? 10. 10 to the 2? 100. 10 to the 3? 1,000. 10 to the 4? 10,000. So what's the correlation here between the exponent and the value? What? As many zeros as the exponent, right? And so now, this should be 10 to the negative 2. I don't know why they're out of order. It should be negative 1 and negative 2 like this. Can we fix the order there? So 10 to the negative 1, 10 to the negative 2. All right, so what's 10 to the negative 1? 1 over 10. And 10 to the negative 2? 1 over 100. 1 over 1,000. 1 over 10,000. Right? But also, if we write those in decimals, 1 over 10 is 0.1. 1 over 100 is 0.01. And then 0.001. 0.0001. Whoa. So what's the correlation there? Whatever, you know, if it's a negative exponent, whatever the exponent, that's how many decimal places there are, right? So negative 3, 3 decimal places. Okay? All right. So now, if I were to ask you then, right, log base 10 of 1. What I'm asking you here is, what should be the exponent of 10 for me to get a 1? What do you think? 0. Right? So I can simply write that as log of 1 is 0. Okay? Now, what should be the base of 10 for me to get a 10? I'm sorry, yeah, what should be the exponent? A 1. So I can rewrite that as log of 10 is equal to 1, right? And if I see it like this, there is no base here, I know that there is a hidden 10. So I say to myself, oh, 10 to the what is 10? 1. Okay? So now, if I have log base 10, 10 to the x, now the base is 10, and I'm asking you, what should be the exponent of 10 so I get 10 to the x? What do you think? What should be the exponent of 10 so it looks like 10 to the x? X. So that's just x. That means log 10 to the x is just x. So remember what we were doing before is if you had log BB, it kind of reduces to just x. All right? And then the opposite, this one I said to just sort of like take my word for it. If you have 10 log base 10 of x, here too, this sort of reduces and I just have x. So if I write it in common logarithm format, 10 log x is just x. So those are the properties here. There's really nothing new, right? It's exactly what we were talking about before, but now just with tens. Okay? All right, why don't we go and evaluate some logarithms? Okay? All right, so here, log of 10,000, the hidden base here is 10, right? So what's the exponent of 10 to get me 10,000? 4, because there are 4 zeros. 10 to the power of log 12, what do you think? That's the pattern. There's a hidden 10 here. So when I have 10 log 10, it reduces, and all I'm left with is 12. Okay. Log 14 is one that we have to do with the calculator because the base here is 10 and there is no correlation here. So let's go ahead and go on our calculators. So log is control 10 to the x. It's that button there, right? Here, it's 14. And there we go. So you see how I didn't put a base of 10, but it put it in there for me, right? So it's 1.146. Always 3 decimal places for logs. Okay, and here, what about log of negative 12? No solution. All right. Now, this was a common logarithm because it occurs most often. So like, what's the Richter scale? It measures the magnitude of earthquakes, right? The Richter scale works with common logarithms, right? So like 10 to the power and so on. Okay, now, that was a common logarithm because the base of 10 shows up very often for logarithms. However, the soulmate base of the logarithm, okay, is a base of e. You guys remember our favorite number e, right? When a logarithm has a base of e, it's called the natural logarithm. Because, like I said, log and e are just soulmates with each other. I mean, log is happy to be with any base. It really has a lot of fun with a base of 10, but when it's with a base of e, that's when like logarithms are like most content. So log base e, suppose you have log base e of 7, right? Because log base e is the natural logarithm, we rewrite it as ln of 7. So log base e gets switched out for ln. Where does the word ln come from? So ln is the natural logarithm, huh?
Logarithm natural.
Okay, so it's the, say that with a French accent now.
Logarithm natural.
Logarithm, that's what it is. It's logarithm natural. That's where it comes from. ln, natural logarithm, good. So, in other words, log base e of 2 is just ln of 2. Okay? So, when I'm walking down the street and I see on a billboard ln of 5, I think to myself, oh, that's just log base e of 5. Okay? So, somebody is asking, what should be the exponent of e so I get a 5? Okay? All right, so let's do some properties with ln's. Now, if I have ln of 1, all right, what's the base here? The hidden base, what is it?
E.
E. So I'm asking, what should be the exponent of e to get a 1? What should be the exponent of e for me to get a 1? E to the power of what will give me 1?
0.
0. Right? So that's why ln of 1 is 0. Now, what if I have ln e? What's the base here? E. So now I'm looking for the exponent of the red e so I can get e. What should be the exponent of e? 1. That's why ln of e is 1. Okay? Now, ln of e to the x, what's the base here? E. So what should be the exponent so it looks like e to the x? Well, that's just x. All right? So again, these are the properties for ln's now, right? ln of 1 is 0 and so on. So take a look at this one. ln of e to the 4.5, that's just 4.5. All right? ln and e together reduce. Okay, so what's ln of negative 2?
No solution.
No solution. What's e to the ln of 4? 4. What ln of 7? We're going to put that in the calculator. So ln is the button in right next to the log. ln of 7. So control E. And that's 1.946. Okay. Take a look here. This is a multi-step one, right? E to the ln of 4, how much does that equal to? That's just 4 minus 2 times, well, what's ln of e? 1. So 4 minus 2, that's just 2. Cool? Okay, take a look at this one. What's ln of e cubed? 3. Plus 4 times e to the ln of 5 is 5. So this is 3 plus 20, 23. Okay? All right. Now for the big ones. What do we do if I have a root? What do we do if we have a root? A fractional exponent, right? Okay. So, log base 25, 5 to the power of 1/3. Okay, now, so this is sort of applying everything we've learned in the last 2 lessons for the logarithms. Okay, now, I have a base of 25 and a power of 5 here. The 25 and the 5, those 2 numbers should be equal to each other. Okay, now, here is the trick. The trick is, I want to write this 5 in terms of a 25. So, when we're dealing with logarithms, we are only allowed to deal with like roots and exponents, right? Now, what can I do to a 25 to make it a 5 as far as roots and exponents? What can I do to 25 to make it a 5? You take a square root, right? Root 25 equals 5. So here, log 25. Can I write this 5 as 25 to the power of 1/2? Is that right? Yeah? Yeah. And then what else have I got left here that I need to tack on? The 1/3. Okay, so you see what I did here. Let's repeat the thought process one more time. I have a base of 25. I need to make this number a 25. Well, are 25 and 5 related? Yeah. If I take this number, the 25, to the power of 1/2, I get 5. So I replace that 25 to the 1/2. And then the 1/3 comes down. So now I'm left with 1 over 2 times 1 over 3, 1 over 6. Should we do one more? I feel like we should do one more. Let's do one more. All right. Huh? Well, because it was part of the problem, right? It was like cube root of 5. 1/2, it's just the 5 that I rewrote as 25 to the 1/2. So I took off the 5 and instead I replaced it with 25 to the 1/2. Now let's do one more. I'm first going to rewrite this as log 16, 4 to the 1/3. Now, what's 4 in terms of 16? 16 to the 1/2 times 1/3. This is log, oh no, I'm sorry, not log. The log 16, 16 goes away, so 1/2 times 1/3. It's just a coincidence that we got 1/6. Should we do one more? Let's do one more. Maybe we could do one more here. So let's do log. Okay. How about this one? All right. So first we're going to rewrite this as log base 4, 2 to the 1/5. Now what? 4 to the 1/2 times 1/5. This is 1 over 10. Okay? Sounds good? So that is common and natural logs, right? And so the homework for this is from the book, 1 through 24, all in the book. All right?